So I'm excited to talk to you about the outcomes or some of the ongoing outcomes that we have from two projects that we have been conducting, looking at deep soil tillage and its improvements potentially on our soil biology. And this is general soil biology and also particularly on our nematode pests and soil-borne diseases. So the question comes up about the impacts of soil-bornes within the deep tillage spectrum when we have this appetite moving down into the central wheat belt for suitable amelioration techniques, deep soil tillage being particularly what we've been looking at by the growers in this region when they're looking up to the north where such good outcomes are occurring. And these are the areas that we also see the impacts coming through as major constraints from our soil-borne diseases and nematode pests. So we've been running this project, as I said, highly collaborative project with other teams, where we're looking at the expectations of success, what style of deep soil amelioration will be most successful, and we're particularly looking here with our work of what style is successful when you have highly mitigating, constrained soils with our soil-borne diseases and nematodes. And we're also been looking at, are there things that you can do? As you know, it was good that we came after Ron's presentation because we're big advocates for crop rotation. So is manipulation of your paddock prior to prior to amelioration going to carry through to that post-amelioration phase and be longer term? So the basic questions that we've had for this research are in three parts. A new profile. Are we able to actually ameliorate our soil-borne diseases and nematodes through deep soil tillage? What are we doing with that new profile? Are we able to improve our soil biology? Are we actually going to knock it about in a negative way with the different amelioration techniques? And the third question has been, of course, is crop rotation prior to amelioration going to help us in the post-amelioration seasons, particularly over a number of seasons post-amelioration? So we've got 4 representative sites that we've been concentrating on. These have been chosen because they have major constraints in the paddocks that are both physical constraints as well as the soil-borne disease constraints. I'm not going to speak about Muresk, it's too new, but I am going to give you examples of the good outcomes that we've had in this project from Yerracoin, which is a more sandy loam soil, Williams, which is a duplex loam gravel soil, and Darkin, which felt like just pure gravel. But I don't think that Steve would characterise it that way. So it's our usual culprits. We are looking at Rhizoctonia solano, one of our biggest constraints in the soil-borne disease world. Rhizo is a natural aspect of our paddocks, so it's not surprising our soil-borne critter is in 50 to 80% of our cropping paddocks. And unfortunately, most of our major crops that we grow in Australia are susceptible to rhizo. Now, when I'm talking today, think about the fact that rhizo is a fungi, so it actually develops a hyphal mat naturally in that top 10 centimetres of our soil profile. And what happens after you ameliorate that soil to that hyphal mat as we move it to different regions in the profile? Our root lesion nematodes, on the other hand, obviously my favourite critters, are also a natural part of our ecosystem here in Western Australia. So they are in more than 80% of our cropping paddocks. A lot of our crops are susceptible, but we, with root lesion nematode, do have some options with our legumes. Both rhizo and root lesion nematode, a number of our weed species are also susceptible, or more concerningly, that they are tolerant to rhizo or root lesion nematode, but still are susceptible and increase the levels. When we think about the nematodes in respect to amelioration, nematodes are an animal and they're a migratory parasite. So it will behave differently to rhizo, and being a migratory parasite, they actually do have that ability to migrate through the soil profile, and they actually swim through the soil pores. So the deep soil tillage that we undertook at those sites was deep ripping, soil mixing and soil inversion. And at each site we compared this to a no treatment or a no amelioration treatment. 5 minutes up, down, up, down. Okay, so when we look at the disease triangle, which you'd all be very familiar with, these are paddocks at Darkin and Yerecoin, also at Williams, where we've had the usual rotation of susceptible crops. Canola is a better one for rhizo, but not for root lesion. Then at Williams, we had 4 rotation crops, which would either increase or decrease root lesion nematode, and unfortunately not do as much for Rhizoctonia, but barley is the most susceptible of those 3 cropping choices that we had there at Williams. And then basically post-amelioration, we continue to throw rocks at those paddocks. And by that I mean we continued to subject the paddock and the new environment to susceptible crops to both of our critters. So when we talk about, firstly, what has happened to our rhizo and neglectus, they are naturally sitting in the 10 centimetre profile, top 10 centimetres of the profile. So when we are changing the soil profile, we are moving them obviously into different parts of the soil profile, away from that top 10 centimetres where they usually cause the issues. So this gives a really good example from Yerecoin. When you don't ameliorate your soil and you grow a wheat, a barley, and then 2021 we grew a canola, we had smashing levels of rhizo by the end of 2020, which was one of the reasons that we did put canola in. And we had our root lesion nematode just hummed along quite nicely through those seasons when we didn't do amelioration. The canola did bring our rhizo down, but not to the kind of level that you would hope for with a rotation crop, and that's to be expected when you allow it to get really high. So that's when we don't ameliorate the soil. When we looked at our 3 types of amelioration at the end of 2021, the good news story was that all 3 sets of ameliorated soil types did actually reduce the rhizo level to a low, which is a promising outcome. But overall, throughout the 3 seasons that we've looked at so far, it's the soil inversion that was by far the best option for these soil constraints. Soil mixing was probably the second out of the 3, but deep ripping really did very little to help the profile. What's also of importance with what we've been doing, this is looking at Darkin and Yerecoin, where we've had those 3 seasons already. And we've moved our pathogen and pests down through the profile through these practices. And the reason this is important is because it's still there. I mean, in the first season, at the end of the first season, we're doing a DNA test, so we weren't sure if the rhizo and the root lesion levels that we were getting were just an artefact of dead organisms that were still giving us a count for DNA. But we're now 3 seasons in, and we're still seeing that when you have spaded, particularly at both sites for rhizo, or when you've inverted your soil for the root lesions, they are there. They're not increasing their levels, but they're still obviously going through their life cycles at those depths in the soil. And that may have implication for the plants as they grow through the season. So when we look now at the soil biology, remembering that the soil biology is ultimately critical for our soils in our nutrient turnover, and our organic matter breakdown, and that we're taking that from the top 10 centimetres where basically all of our, not all, but most of our soil biology is existing, and we're moving them to different degrees depending on what amelioration practice that we're undertaking. We've used nematodes as a tool in these projects, And this is not new science. Using nematodes as a tool is research that there's a whole arm of research that's been dedicated to using nematodes as a tool to indicate soil health, going back to the 90s, and it's been very successful, depending on where you are and which research you're doing, of course. What is new is that SARDI have been developing a molecular test in order for us to do this on our Australian soils particularly. The way that this test works is you look at both the diversity of the different feeding groups, which represent different types of organisms in the soil, from fungivores, bacteriivores, and to our higher level feeding groups. So we are looking at structure. We get that from our higher levels, nematodes that are longer lived, more fragile, and more likely to be impacted negatively by inputs like nitrogen or other things like that. We have our boom-bust bacteriivores and fungivores, which give us an indication of enrichment and balance within our soils. And then obviously we have the plant parasites, which we're trying to avoid. So we had 3 major outcomes so far in this project as far as this is concerned. The first is that when you immediately ameliorate, so we did intensive soil sampling immediately after we have done the amelioration at the beginning of the season in 2019. And what we found in that topsoil was, as you'd expect, inversion, where we've literally taken the topsoil and put it at the bottom of the area that we've ameliorated, that you did have less soil biology. On the other hand, we had not negatively impacted, compared to nil, in our other moldboard, in the ripping or the spading options. And this is a positive because, we did expect that our bacteria and fungi may have had a spark because of the new aeration and the getting rid of the compaction at the site. But we were concerned that our structure would be compromised by that quite aggressive styles of amelioration that were employed, and that didn't happen. So that was the first positive. The second positive has been that the changes that we've made to the soil biology by the end of the first season have continued over time in the first 2 seasons. So this is positive. We actually, by the end of that season, we saw a stimulation of the soil biology within all 3 of our amelioration techniques, much less so for deep ripping, but actually soil mixing and inversion both had a positive impact on the soil biology. And this has endured through those first 2 seasons. Now, last season, everything was different, including the crop. So we had quite an altered soil biology by the end of 2021. We're not sure whether that was due to canola being such a different crop or whether it was due to it an ongoing, we're now 3 seasons post-amelioration, or whether it was because we had the wettest season and the biggest crop that grower had seen. So 2022, it'll come out in the wash now that we've got another barley there. We're looking forward to that. The third good outcome that we had with this research as far as biology is concerned is that your soil biology is enduring over time when you've moved it to depth, and those increases are happening particularly, again, less with the ripping, but with the moldboarding and the spading. Something to bear in mind is that there is a direct relationship. This is giving an example from our sandy profile at Yerracoin. There is a direct relationship to where you have, this is showing correlation. The top is the nitrate nitrogen, the bottom is the organic carbon. Where you have higher levels of free-living nematodes, which indicates higher level of soil biology, you have higher levels of that nutrition. And those two, obviously, these things go hand in hand. And at Williams, where we've had a closer look at the soil chemistry, we have those sort of changes, that correlation happening with organic carbon and nitrate nitrogen. We also have it following through with potassium, magnesium, iron, etc. So that's something that we will follow through this season and see if those increases continue. And there's a lot more to do with this data. Excellent. Okay, so very quickly, this is a whole talk in itself, so I'll answer it very quickly. Does your crop rotation prior to amelioration matter post-amelioration? And the resounding answer is yes. When we had barley, Maximus barley, over the top of those 4 crops last season, we had a great increase from lupin and ceradella compared to barley on barley. And we had also almost a tonne of improvement where we had done amelioration compared to not. And because my time is up, I will thank you.